Hi, boys and girls. It's Mrs. Marburger. I'm here with an equivalent fraction lesson for you. I don't know the best way to do it. Last week, I kind of did it on a screencastify where I worked through the worksheet with you. Today, I decided to put it up on my wall. It's going to be a similar type of lesson. This one takes it a step further. If you're up for a challenge, I'm going to show you what that is. So let's remind ourselves how we are going to find equivalent fractions. These first three problems are the same first three problems that are on your worksheet that I have assigned for you this week. So I'm giving you the first three answers. So you know that you'll have those right. And then you're going to finish the rest of the page. It goes all the way to number 16. There's a total of 16 problems. Last week, some of the kids only did part of the problems, and I think the reason is that you guys didn't scroll down to the bottom of the page, so there were some that you missed, which is not a big deal. But I'm just letting you know this week that there are 16 that need to be completed. Also, this week, you're going to see that below the worksheet is the answer key, and I'm asking you to please, you need to do all of your problems, 1 through 16, before you go to the answer key. All right, that's because, like I said last week, if you don't do the work, don't put the time in to figure this out now, and you just go and look at the answers and then say, oh, look, I got all the answers right to your mom or your dad or whoever, you're just hurting yourself, right? So you really want to take the time and make sure you're doing the work, and then you go back and check it and see which ones you struggled with. Maybe there were some that you need to check again, or maybe get help from mom or dad, or maybe reach out to me or stop in during my office hours, or reach out through an email and say, hey, can we meet online so that you can explain this to me, which I am available, so don't forget that. Okay, so let's look at number 1. 3/4 equals blank over 8. So remember, we're going to look at, we have both denominators here. So we're going to look at this, and we're going to say we had 4, we went to 8. What did we do? What did we multiply that 4 by to get to 8? Well, you should know that 4 times 2 is 8. So what you did is you did times 2. Now remember, whatever you do to the bottom, you're also going to do to the top, to the numerator. So we're going to also do 3 times 2, and that will give us the new numerator. So what is 3 times 2? That is 6. So 6 is the answer to number 1. Now, do you remember how to check it? To check it, we do our crossing over. So 8 times 3, that's 24. 4 times 6, that's 24. So both of those answers are the same. That means we know that we have equivalent fractions there. That's just an added step to check yourself. Okay. Is it all coming back to you now? Are you remembering how to do it? Oh, I know you are. Okay, so let's look at number 2. For number 2, we have both numerators, but we're missing this denominator. So let's look at these numerators. 5 and 20. Well, we went from 5 up to 20. That means we're going to be multiplying because the number's getting bigger. So what are we multiplying 5 by to get to 20? Hopefully you know it's 4. So 5 times 4 gives you 20. So that means, what am I going to do down here? I don't have that smaller number to multiply by. So we're kind of going to have to go backwards. Guess what we're going to do? we have the 12, we're going to divide it by 4. Okay, so what is 12 divided by 4? Or another way you could think of it is, what number times 4 will give you 12? That's the way a lot of you like to think about division. You like to turn it around into a multiplication problem, which is a very smart thing to do. If you're better at multiplication, turn the division into a multiplication problem to help you out and help you get the answer a little bit faster. So in your mind, you could be thinking blank times 4 equals 12. So what would go in there? What number? Would it be 1? Would 1 times 4 equal 12? No. Would 2 times 4 equal 12? No, that would be 8. Would 3 times 4 equal 12? Yes, it would. So this answer is going to be 3. Okay, so then if you want to check it, remember we go back and we cross-check. Now these problems are a little bit bigger. We can do 3 times 20 pretty easily, right? That's just 3 20s. And we should know that that is 60. Now 5 times 12. Well, remember we talked last week, if I want to do 5 times 12, break that 12 into 2 smaller numbers. I like to pull the 10 out. So I'm going to do 10 and 2 to make up my 12. So I would do 5 times 10 is 50. 5 times 2 is 10. And then I add them together and I get 60. And that is the same, so I know my answer is correct. Okay, one more. 11 seconds, or 11 over 2, equals 33 over what? All right, so we have both numerators. 11 to 33. It's getting bigger. That means we're going to be multiplying. 11 times what will give you 33? Well, 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. So it's going to be 11 times 3 gave us 33. That means we're going to do the same to the bottom. 2 times 3, and that's an easy one, 6. Now, if we cross-check it, we could do 6 times 11 is 66. 2 times 33. You might be thinking, oh my gosh, 2 times 33. That's a really tough problem, but really it's not. It's just 33 2 times. So it's 33 plus 33. And that'll give you 66. And they're both the same, so I know my answer is the same. Now, when I started the video, I told you that there was going to be a little bit of a challenge in here. So I don't know if you noticed, but in some of these problems, for example, number 2, the numerator is larger than the denominator. I'm going to take this right here as an example. I'm going to write it right here. 5 over 3. So do you notice the numerator is larger than the denominator? Well, when that happens, oops. Sorry guys, this is not ideal. I know, I'm sorry. It's not sticking to my wall for some reason, so I had to stick it to my picture. Anyway, back to work. When the numerator is larger than the denominator, it means it's more than one whole, because remember, one whole would be 3 over 3. 3/3 is one whole. This is 5/3. That means it's more than one whole. What that would look like if I were doing a drawing of that. So if we have thirds, that means, let's say our candy bar is divided into 3 equal pieces, because that's what this number tells us. The denominator tells us how many equal pieces it's cut into. Okay? But see now, the top number tells you how many of those pieces I'm focusing in on. And it says 5. So that means I need 5/3. Now remember, each one of these is 1/3. Because the candy bar is cut into 3 pieces, 3 equal pieces. So if I need 5 of those pieces, that means I need this one, 1, 2, 3, 4, 5. So if I look at this, 5/3 is the same as having one whole and then 2/3 of that second candy bar, isn't it? So 5/3 is the same as 1 and 2/3. Does that make sense to you? Is that mind-blowing? Hopefully this picture helps explain it. This one down here, 11 over 2, is the same kind of idea. 11 is bigger than 2. That means it's going to be more than just one whole, right? 2 over 2 would equal one whole. This is 11 over 2. So let's see what that would look like. Okay, so that means, I'm going to do it right here. Looking at 11 over 2. That means our candy bars are cut into 2 pieces. Remember, the bottom number tells us how many equal parts it's cut into. So this candy bar is cut into 2. These are all cut into 2. I need 11 pieces. 11 equal pieces, okay? So that's going to definitely be more than one candy bar. Let me draw some of these out. Now remember, each one of these candy bars is 1 over 2, or 1/2. So this is 1/2 of a candy bar, this is 1/2 of a candy bar. Each one is 1/2. Now I need 11 halves. Wow. So that would be, let me use a different color so it really stands out. If you need 11 halves, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow. So now take a minute and think about this. How, just like over here, we had one whole candy bar and then 2/3 of the second one. So it was 1 and 2/3. What would the answer to this one be? I'm going to give you a couple of seconds to think about it. How many wholes and then how many parts is it? Okay, let's check. This is one whole candy bar, so that's 1. holes. Here's another hole, so now we have 2. Here's another hole, so we have 3. Another one is 4. Another one is 5. So we have 5 whole candy bars, and then 1/2 of that last one, right? So it's 5 holes and 1/2. So 5.5. Wow. Did you get it? Do you know it was 5.5? Bet you did. So this is the challenge for those kids that are breezing through equivalent fractions and you're not having any issues figuring out what the missing number is. Challenge yourself, and if you notice that the numerator is larger than the denominator, see if you can figure out what it would be if you put it into, this is called mixed numbers because it's a whole and then a fraction, a whole and then a part. So see if you could figure out how many wholes and how many parts it would be, just to challenge yourself if you want to. If not, if you're still really working on just getting the equivalent fraction, then just go through and do the regular work. That's fine. Okay? All right. Something else that I did want to tell you. If you want to cross-check, if you want to use a calculator to cross-check, say you come to a really tricky problem. These aren't really tricky, but if you just want to double check yourself, you can pull out a calculator and just double check to make sure, oh, yep, that was right. I don't mind you doing that, okay? And remember, reach out if you need any help. I hope this was helpful. Good luck with the worksheet, and let me know if you get stuck. All right, bye guys. Oh, and remember, do not look at the answer key until you do all the work. I'll know.